I'll show you what we got.
Yeah.
So I don't already talked to you about 26 hours, so I'm going to skip that. I'm going to talk to you real quick about our main product that you can find at the URL right there. It's called Kazoo. So what is Kazoo? Kazoo is a scalable distributed cloud-based platform that allows you to build powerful telephony application with a rich set of APIs. So what does that mean? In practical terms, it means that you can create your own services in the cloud, in your mother's basement, or like in a distributed cluster environment. It's all up to you. So real quick, what is WebRTC? You guys should all know what it means. Web real-time communication. It enables voice, video, and file sharing on your browser. So how did we get WebRTC into Kazoo? So two parts are required for us, backend support, which I'm going to talk about today, and a front-end support, which Max will talk about after. There are multiple layers of communication that we need to enable for WebRTC to work. So I'm going to real quick go through these. So we have our web router. We have the whole transport mechanism is wrapped in what we call a TCP socket. So that stands for Transmission Control Protocol. I will refer it as my main pipe. Inside the TCP socket, we have our WebSocket, which was introduced in the browsers with HTML5. It pretty much allows you to push data from the client to the server, but more important, to the server to the client. Our WebSocket then gets translated to SIP. So SIP stands for Session Initiation Protocol. Once we get that SIP, it then gets translated to RTP packets, and that's where the actual audio and video are. So how did we get all that into Kazoo? So I'm going to show you our schema on how we did that. So first, again, we have our WebRTC enabled browser that connects via a secure SSL connection to our media server. In our case, our media server is Cameo. It connects via Chameleon's WebSocket module. Then we do that translation to SIP. So if you remember, that was our second step in the previous schema. These SIP packets then are being transferred to FreeSwitch. FreeSwitch then relay the audio and video via the RTP packets directly to the browser. So that's how we implemented WebRTC into Kazoo. But before WebRTC, there was Flash. So if you guys ever use Flash, thank you. It's really helping. So we have also the need to enable Flash for all the browsers that are not supported by WebRTC. So you saw in the previous presentation all the browsers were not, i.e. I think Opera was not, or was it Safari? Okay, so we had to implement what we call RTMP also, which is a different protocol. It stands for Real-Time Messaging Protocol. It was also developed to stream audio and video and data. And it's actually currently owned by Adobe, same as Flash. So we did a whole implementation of RTMP also. So we have a Flash application running on your browser that talks directly to our RTMP server. The RTMP server then translates that directly into SIP back into Cameo. Like before, Cameo send it back to FreeSwitch. FreeSwitch then send the audio and video directly back to the RTMP server, which then relate to your Flash application. So I would like to make a point that WebRTC is hard to see on that schema. A couple of reasons. You don't have to actually install anything. WebRTC is enabled in your browser. If you use Flash, you have to install Flash. Second thing, your connection is secure. This is not a secure connection at all. This is. Third point, RTMP does not support any HD audio codec. So if audio quality matters to you, you should definitely go this way rather than RTMP. And also our implementation of WebRTC is way more robust, as you can see, than our really simple RTMP servers. So we really encourage people to WebRTC rather than RTMP. On that note, I'm going to give the mic to Max, who's going to talk to you about how we actually implemented it on the front end.
Thanks. Let me just everything else again. All right. So, yeah, Peter talked to you about how we did the things in backend. I'm going to explain to you how we build a web user interface for WebRTC. So, to build a user interface, obviously you need some basic HTML and CSS. We're not going to cover that because obviously it's not related. It's not only related to WebRTC. So, where all the important stuff is done is in the JavaScript. So, as you saw before in the previous presentation, there are several libraries that do WebRTC. They were using JS-Zip, I think. We are using Zip.js. You also have ZipML5. I'm sure there are plenty of libraries that do that. But we decided to create our own library. Of course, we are using it's on top of Zip.js, so we're still relying on them to do all the WebRTC connection to Zip. So why did we have to build our own library? The reason is very simple. Peter talked to that a little bit before. It's because of RTMP. So yeah, RTMP stands for Real-Time Messaging Protocol, or Really Terrible Mother-Loving Phone, which is very accurate. It's a terrible thing. But we still need to use it for one simple reason. WebRTC is not yet supported on all browsers, as you could see before. Unfortunately, Internet Explorer and Safari are not supporting WebRTC right now. There are still a lot of people using those browsers. So if you want to gather to a huge audience, to be able to respond to the needs of everyone, well, you need to be able to handle RTMP as well. So that literally is the only upside of RTMP. It's because it's using Flash, and Flash is virtually everywhere. It's available on every browser. It has many downsides though, as Peter stated before. You have poor audio quality with that. There is no echo cancellation, which results in a really terrible user experience, kind of like that. It's pretty hard to support on the back end. It's also a proprietary protocol. It's owned by Adobe, and it means that there is not really any room for evolution in that. So how does it work, our library, the Kizu.js library? Well, basically we are using two open source libraries. The first one, as I said, is Zip.js for the WebRTC part, and the second one is Flash Video IO to handle all the RTMP parts. So it does with two simple steps. The first one is to check if your browser is compatible with WebRTC, and if it is, it's only gonna load the Zip.js library. If it's not, then it's gonna check if Flash is installed on your browser. If it is, then it's gonna load the Flash Video IO library. And again, if Flash is not installed, it's gonna send you a message telling you to either install Flash or change your browser, basically. So the really important part about that is some libraries are pretty heavy. It's especially the case for Flash, which loads a Flash component on the browser. So the point of that check is that if WebRTC is available, we don't even load that library, so you don't have to go through the hassle of loading all the stuff on the browser. And the last important, sorry about that again. The last important part, might try like that. So the last important part is that it's a common set of functions for those two libraries. So as developer, you really don't have to wonder which library you're going to use. You don't have to bother with that. You're using the exact same set of functions, and our library is going to do the magic behind to deal with the right one. So I'm going to show you a little bit how to use it. It's user demonstration before with Voxbone. It's pretty much the same kind of usage. So I'm going to go quickly over those functions. The first step is to initialize the library, obviously, and you have several parameters for that. You have this option, the first RTMP. It will force the RTMP to load no matter what. There's no actual reason to use that purpose because you don't want to use RTMP at all, but you still need to test it if you're going to implement it. So that's the only reason to use that parameter. The Flash container, well, when you're using RTMP, it requires, as I said, a Flash component on your browser. And with this container, it's basically an HTML ID that you provide, and you can use that to specify where you will want that component to be appended on the web page. If you don't specify it by default, it's just going to append it on the body of your web page. Then you have a callback on Flash move, a function that will be triggered if it's going to load RTMP, but Flash is not. Or you have an old version of Flash that is not supporting RTMP. So you can use that to send an error message to your user and indicate them to either install Flash or change browser. And finally, you have a callback when the library is loaded because some of the library, especially the Flash one, bit of time to load, so you want to wait for it to load before you actually display your user interface. So that's the callback you're going to use for that. So once the library is initialized, the next step is to register a SIP device, especially if you want to receive call. That's important. So to register it, you have several information to provide. First, you have the WebSocket URL for WebRTC, and your URL for. So in theory, you only need one of those URL, but if you don't want to bother which one it's going to use, just provide the two of them, and obviously the library will figure out which one to use. Then the SIP credentials, so those are pretty basic. You have to provide I can put it on the computer. The one, the private and public identity, and the password. And then, I'm sorry, give me a second. Then you have a set of callbacks again. So if you're not familiar with web development, the callbacks are really like events. Those are functions that will be triggered when something specific happens. So the first one, unconnected, is when you successfully register your device. You can use that, for example, to display a light on the web page to tell the user that the device is now registered. You have an incoming, which will be triggered whenever you receive an incoming call. So you will use that to either accept or reject the call. Unaccepted, well, that's when you're placing a call, and well, you get notified when the other end accepts your call. On hang up, again, that's the opposite, when the person hangs up. And on error, which will be triggered, for example, if you provide the wrong SIP credentials, you will get some authentication error. And then we have a set of basic actions. So there are actions that are available, but those are the most common one. So connect to the call, DTMF, toggle your microphone, transfer a call, and hang up a call. So use a phone number for the first one and an extension for the transfer, but those are really just SIP URIs that you can you can place a URI with that, you can place a number, anything that you will be able to call with a normal phone, basically, a desk phone. So yeah, that's it for the JS library. It's pretty simple. Again, the really important part is the fallback on RTMP. It allows you to re-support phone calls on every kind of browser. You don't really have to to wonder the compatibility and all that stuff. It will do everything for you. That library is open source, so you have access to it on our GitHub repository on github.com/2600Hz. Yeah, I think that's pretty much it for the library. So some basic use case for WebRTC, because they covered that a little bit before in the Voxbone presentation. But the really important thing to understand is how powerful WebRTC is. So the first one is obviously a soft phone on the browser, just to be able to place call like you will do on a soft phone. The great upside of that is that you don't have to install anything, so you can virtually access it from everywhere, which is really convenient, I would say. We actually at 2600Hz are working on that. We are always, there is no dates, but we'll be working on a soft phone for our Monster UI, our new UI. That's in the pipe. There is no doing that. Some other use case, you have the click to call. They cover that pretty well, I think, in the previous presentation. You can do some really powerful stuff and just simply put on your web page, click here to call the support and just ring the support directly from your browser. You could create a voice chat room, a conference room, and again here that will allow you to use our set of APIs that we provide at 2600Hz with Schedule, where you could use WebRTC to connect to place all the calls, and then use your API to see who's connected to the call, to the call actions on the conference room and all that stuff. So you can really use WebRTC in pair with a lot of different tools. And again, just use your imagination. There are a lot of possibilities to do. Those are some just basic use cases, but I'm sure a lot of smart people will figure out great stuff to do with WebRTC. So yeah, to conclude on that, I think again WebRTC is a young but really promising and powerful technology, and the possibilities are really endless because it allows audio, HD audio, obviously, but also HD video, file sharing, screen sharing, conference application. You can do a lot of stuff with that. I think that pretty much covers everything. Thank you for everything. Do we have? No, we don't have any. Oops. Well, that was the last slide then. Thank you for everything. Thank you for coming and listening to us. And if you have any question, here.